Well, okay, in this video I want to show you how to take a right triangle and to solve the triangle using SOHCAHTOA. And in this lesson we're also going to use inverse trig functions to figure out angles. So here I have what is a 3, 4, 5 triangle. I've omitted the 5 as the hypotenuse just because it's good to know to use the Pythagorean theorem in order to find the hypotenuse, but we can also use trigonometry. Particularly in this lesson, I want to show you how to find angles A and angles B, and then using the Pythagorean theorem, we can find the hypotenuse. So the hypotenuse has to be 5. So okay, here are some things that I know about the triangle, and I'm going to give you the solutions first, and I'm going to show you how I found the solutions. So I know that angle C is 90 degrees. Does that make sense? It's got to be 90 degrees. There's the right angle box, and so it's a right triangle. So angle C has to be 90 degrees. But I've also discovered using trigonometry that measure of angle A is about 37 degrees, and the measure of angle B is about 53 degrees. And it's this particular lesson that I want to show you how I found that out. So okay, how did I find that out? Well, first what I did is I concentrated on finding angle A. And I noticed that 3 inches is opposite angle A, and that 4 inches is adjacent to angle A. So I go back to SOHCAHTOA. Remember, S stands for sine, C stands for cosine, and T stands for tangent. And so the question is, from the picture, knowing that I have an opposite and an adjacent, when do O and A come together in SOHCAHTOA? Well, immediately following tangent. And so it's the tangent function that I'm going to use, opposite over adjacent. So what I have to do now is I have to establish an equation. And so this is the equation that I establish. The tangent of angle A is 3/4. Now to solve for the angle, what I have to do, excuse me, is I have to get rid of the tangent function. And the only way to get rid of a trig function is to use its appropriate inverse. You can't divide by TAN. You have to use the appropriate inverse. And so what I do is I apply a tangent inverse to both sides of my equal sign. And what happens is, on the left, tangent inverse and tangent, these two functions cancel each other out. So I'm left with the measure of angle A. Well, the measure of angle A is going to equal the inverse tangent of 3/4. And I have to make sure my calculator is in degree mode. If I do, I type it out, then my calculator gives me this wacky decimal. 36.869896765 degrees, approximately. What we're going to do in this class is we're going to round to the whole degree. So because the decimal point, the 8 is larger than a 5, I am justified in simply rounding this to a whole number, 37 degrees. And so this makes angle A 37 degrees. There are 2 ways to figure out angle B from this point on. One of them is pretty straightforward. Since this is a right triangle, angles A and B have to be complementary, meaning they have to add up to 90. And if I know that angle A is 37 degrees, well, that means that angle B would have to be 57 or 53. And that would make them the two angles complementary. But there's another way to figure out angle B that I think is worthwhile, because remember, we're still learning SOHCAHTOA. This is still kind of new to us. And so I think the other way is just as good right now because it makes good practice. And that is to use SOHCAHTOA from the perspective of angle B. And so notice that opposite angle B is the 4 inches. And adjacent to angle B is the 3 inches. And so I am perfectly justified in establishing the following equation. Tangent of angle B is equal to 4/3. Now I have to apply the appropriate inverse to both sides, which is tan inverse. Tan inverse of tan B simply becomes the measure of angle B. And the right-hand side becomes the tan inverse of 4/3, which the calculator gives me this gorgeous-looking decimal number, 53.13010235 degrees. But this 0.1 is not enough to round up the 53 to a whole number of 54. So I say that angle B is approximately 53 degrees, and as long as 53 degrees is complementary with 37, I'm safe. And lo and behold, I'm safe. Now, we're just going to use the Pythagorean theorem to figure out the hypotenuse. 4 squared plus 3 squared has to equal this squared. Well, 16 plus 9 is 25, and the square root of 25 is 5. So this is 5 inches. And so that is how we use SOHCAHTOA to solve this particular right triangle problem. God bless you, wherever you are today.